Hello everyone, welcome back to VLSI for All. I'm Neeraj Kumar Cheryala, back with yet another expert stop on VLSI industry and career. And this time we have Bert Verrycken joining us from Portugal. He has 25 plus years of experience in semiconductors. He's currently working as director at Inatera, and he has involved in many chip tape outs. Some of the chips he was involved in or closely associated with are Accelera AI accelerator. He was involved with ASIC and UVM, and the other one is Mythic AI Analog AI Accelerator. He's also written an article about it on LinkedIn. And there are many other AI accelerator chips, one of which is from Intel Movidius Scheme Bay, and all the other Movidius chips related to computer vision and AI accelerators. Previous to working as director of verification at Inatera, he was also working as a technical writer with 60,000 plus Quora space, and all of which is involved in semiconductors. He was principal engineer for verification, and he was also a team manager at Accelera AI, and another company that works on AI chips. He was also involved in ASIC mixed signal design and verification at Mythic, which is now famous for developing analog AI accelerators. He has also worked as ASIC mixed signal design and verification at Analog Devices, ST Microelectronics, and he has a vast experience in this field. Thank you, Bert, for joining us today. We are glad to have you with us.
Yeah, thank you very much. I'm glad to be here as well. Thank you.
Yeah, so before we begin with the questions, although I've introduced about you a bit, our audience want to hear it from you. So could you please introduce yourself to the audience?
Okay. Yeah, my career started actually in the 90s when I graduated from the university. I started immediately working for a subcontractor for various bigger companies, let's say, in the semiconductor industry, like Philips. Back then it was called Philips, but it's now called NXP. So USB devices, for example. I worked for Alcatel Microelectronics, for Alcatel Bell, ADSL modems, for example. I worked also for Motorola, did an audio processor. We worked for Philips DECT telephones back then, the DECT protocol, which is still used. Yeah, there were various big companies that we worked for. It was always 3 to 6 months projects, which was very interesting because you learn a lot in a short time frame, let's say. So it was a very interesting period to grow very fast in knowledge, I think. Later on, I joined NXP directly, the USB device group. And then I worked for various companies, big companies in the automotive and industrial space until 2010. And then I started actually working freelance. And when I started working freelance, I worked on Bluetooth low energy devices. Then I worked on satellite modems. And then around 2015, I think my career went into the direction of AI, artificial intelligence, ASICs and chips. So I started working for Movidius a few years, and then later on, I with ADI in between, I then worked for Mythic Accelera and now Inatera. So yeah, I specifically want to learn a lot about artificial intelligence because it's a really interesting space. And I think AI is going to change the world. So yeah, that's where I am now, trying to increase my knowledge about the different AI networks that are out there and the ways that the hardware accelerates these mainly software-based algorithms. So
yeah, that's quite a journey. Interestingly, you were involved in those parts which were accelerating at that time frame. For example, you were involved with modems and BLE, right? So those protocols, they were accelerating at that time from when you were involved exactly. And now the same with AI chips. AI chips are on the rise right now, and you are involved with AI chips. So that tells us that you've got, a good direction overall in your career right from the beginning. So you have been in semiconductors for the past 25 years. So
Mhm.
what's the difference between the semiconductors now and the semiconductors then? We would like to hear it from you.
Well, yeah, in the 90s, we were actually we didn't have any UVM verification methodology, for example. All the projects were very small, let's say ASICs, 20K gates, 100K gates. We were prototyping them mostly in FPGA and then going to an ASIC, let's say. So our teams were very small. When I remember in 1998, our teams were sometimes 2 people, a very senior engineer and a more junior working together, or 3 people or 5 people, but we didn't have the teams that have the sizes now with 100, 150 people if you include all the software and firmware people. So back then it was a matter of doing all the things yourself. That means you were able to design, to verify, to synthesize, to do static timing analysis, to do the gate level simulations, to do the DFT insertion, and then go to the customer, because I worked for a consulting subcontractor firm in the beginning. We also had to go on site, do a little bit of bring up, let's say, silicon validation, or for the FPGA, the prototyping, develop some specific boot firmware or something very small in the embedded software world, let's say. So back then we were really integrated with the whole project design cycle in the front end, let's say, not the back end, but the front end, everything until you deliver the netlist to back end. The back end did their magic, came back to us with problems maybe or things that we had to solve in the design. And then we did gate level netlist simulations, pre and post layout, and compare them. So we did also logic equivalence checking between pre and post layout netlists. So yeah, it was a very interesting time back then, but it was all possible because the projects were so small. Today you have a lot more partitioning. So you are either a design engineer, or you are a verification engineer, or you are a synthesis STA engineer, or you are a DFT engineer, which is a little bit of a pity because the links between all the front-end tasks have a little bit, let's say, deteriorated, or people are not always aware anymore of all the details that are very important in the whole ASIC design front-end project, let's say. And that's a little bit sad, but I think because of the size of the project, it's understandable. But I think it's still very important for people to understand the links between the different activities, and to if they can move to different positions in the team to experience how a design team works, a verification team works, how the synthesis is done, how the DFT works, and all these things. Yeah, I think that is the main observation that I have, what was before in the 90s the case and what is now in 2023.
Yeah, so that's an interesting observation. Even I wanted to ask the same in further into the session. But is it still possible for the guys who are just starting out to join a startup and do all of that? Is it still possible? What do you think about it?
It's very difficult for juniors to get into a startup because startups have a certain limited budget. So they compete with the big companies usually on the market. The big companies have hundreds of millions to spend on a tape out, while a smaller company, a startup, let's say, they have like 20 to 50 million to do a tape out. And that means they search for people with experience. So they need to have people that can join and immediately be effective and doing the things that they need, because they have a strict budget to they cannot take in a lot of juniors to get them up to speed and develop them before they actually are useful into the verification or design or synthesis things that need to be done for the tape out. So unfortunately, that is not always possible, but I think there are possibilities. For example, I hired for Accelera a bit more junior people, but that's not always possible, I'm afraid.
Okay, so is it possible for a guy to just explore all those fields, let's say in front end, by switching the roles, as you said internally? Is it also possible to switch roles by switching companies itself? So let's say he was hired for logic design in one company. Later on, he wants to explore verification. So he can switch up to other company, work for verification there, and go on. But it would be difficult, right, for him or her to get hired in other companies if he or she has already got experience with logic design, let's say. So what would
Yes, that is the problem. I experience that all the time, because I started out as let's say a designer, but when I started working, you start not as a designer, because you first need to verify. And if you verify blocks, they can see how good you are in thinking about the design and how to stress the design, and get to know also the design guidelines and how designers use the synthesizable subset of VHDL or system Verilog. Back then it was only Verilog, but now it's system Verilog. Synthesizable constructs are a subset of the whole language, let's say. So you have to understand that designers only use a certain number of constructs that are synthesizable, and then also tuned to the tool, because the EDA vendors all have a little bit of a different subset they support. So sometimes something that is supported by one vendor is not always supported completely by another vendor, and that makes things complicated. But at the same time, I think it's very important that people, let's say, if you are perceived as a designer, you will need to enter the company as a designer. But if your goal is to go to verification or to synthesis, is to talk to your manager, first prove yourself as a designer, and then say to your manager, hey, I am a continuous learner. I am actually interested in also learning a lot about verification. Could you put me on tasks that are more interaction with the verification engineers, or with the synthesis, or with the DFT people? And then you move into that direction. And let's say at a certain moment in time, then when your yearly or 6 months evaluation comes, you indicate you want to learn more about verification or synthesis, and you say, I want to move to a different group. And instead, if you are valuable to the company, they will understand that you need to develop your skills and your learning. So obviously, if that is not possible, you have to leave. But otherwise, you can, from a design position, move internally to other positions. Getting straight into a verification, for example, from a design position is a lot more difficult, because recruiters, they are not engineers. They usually look to a profile and they say, oh, this looks like a design engineer. That is totally not possible to do verification, and they will just disqualify you. You don't even get an interview to talk about it. So yeah, that's one of the things that I'm writing about a lot, I think, or at least in the past a lot, because now a little bit of time prevents me from writing too much. But the partitioning into categories is a little bit not so nice, because people cannot move easily from a position to another position. And I think it's very important to understand all the front-end tasks. If you know how everything is linked, so if a synchronizer is designed in, how you test that in verification, what the implications are for gate level, but also for STA and synthesis, then you actually know how all these things actually work together, and you avoid problems later in the cycle. Which with the partitioning now, people are saying, yeah, but tape outs are very, very expensive now. That's also because of the tech nodes that are more expensive, but also because of the partitioning, because people in design, they get only feedback after everything goes. First, you design something, you stop designing, you deliver it to the verification team. They do their thing for 2-3 weeks, maybe 6 weeks. Then they goes to synthesis and to STA, and there is always a delay in the detection of problems, so that they get back to the designer when the designer is already working on another thing, and then has to remember, what did I do on that design. So yeah, this partitioning is a little bit the problem, and it's also, yeah, I don't like it so much, also because people, if you want to learn a lot and keep learning, I think it's important to move to the different aspects of the front end design cycle of the project, because later, if you want to lead a project, you also have to be aware of all the subtasks. So if you only have been a designer and never did verification, never did STA, never did gate level simulations, yeah, that's very difficult then to lead a team of consisting of verification, synthesis, STA, DFT, and other tasks. So yeah, to me, partitioning is bad, but I think it's a way of the world, and the size of the teams, the way that recruiting works, is a very complicated, let's say, matter. But I regret that it's happening, because I for one, I like people moving into different positions in the team, let's say, to do the various tasks. And yeah, I think your only value as a person, as an engineer, let's say, is that you have skills and knowledge. And yeah, the more skills you have, the more you become valuable to startups, for example, that need people to pivot to different tasks whenever they need it. They are usually looking for multi-skilled people. So yeah, sorry about the rant, but partitioning is a little bit of yeah, something that bothers me a lot.
Yeah, that's an interesting aspect of industry right now. And generally, freshers like me get frustrated about this. Um
Mm-hmm.
we'll be given a certain part of the project, and we'll be asked to design something out of for that, and we will not be involved in further stages of the design, as you said, verification or STA. So, so as you said, it is always valuable for a company if a guy joining has knowledge on all these subdomains of front end design. Let's say that is the
Mm-hmm.
takeaway from your answer. So, and
Correct.
coming
Yeah.
to yeah, so coming to your various kinds of chips here. So, is there any difference, as you are a verification expert? Is there any difference with respect to verification for chips related to modems and for chips related to AI? That's the question from the audience.
Well, actually, there is not so. Let's say artificial intelligence is mathematics. We are talking about multiply and accumulate and different filters, optimizations, maybe also conversions between floating point and integer. Now, in modems, like in XDSL modems, like ADSL, VDSL, we also have these things. So we have very complicated mathematical constructs to make sure that we transfer the information over a medium like a copper cable, or even in telecommunications for satellite modems, with different modulations and FAC rates, to make sure that certain data streams are error corrected or error detected. And these things are quite similar to AI. So I remember that we didn't have UVM in let's say around 2000 and 2005, when I was also involved in ADSL modems. So we had to invent our own randomization to make sure that the data was randomized, so that you could see that all these error detection and error correction mechanisms inside the chip were actually stressed to the point where you can be certain that in the real life deployment, remember, we only simulate for a few milliseconds at best. In real life, they go on for days, weeks, maybe that they are up and running. We are not rebooting them. So they need to be stress tested in all kinds of situations. And that we invented our own ways of doing randomization and constrained randomization of data patterns and everything that had to do with the parameters. So it's actually quite similar. It's lucky that we have the UVM environment today, that for the AI chips, we have our built-in, everything comes with a class-based system where everything is predefined so that we can customize whatever we need. So UVM has been a great help and an addition to us. But at the same time, yeah, in the past, we had to do something UVM-like to verify these ADSL and modems and these modulators and demodulators for satellite, for example. I see a lot of, let's say, very similar things in both systems, let's say. Yeah.
Yeah, thank you for that answer, Bert. So moving on. So right now, nowadays we are seeing Python is also evolving into the field of verification. Recently, Python-based verification tools have arrived in the industry. So what's your take on this?
Well, I think it's very interesting. There were already Python test benches in the years 2000, in the beginning of 2000. For example, if I remember well, Alcatel had a Python-based verification environment because they wanted something where they didn't have the constraints that VHDL and Verilog back in the time had, because they were mainly designed for designing chips. So they were based on a concept of translate everything into hardware. So when you want to do behavioral things, calculations, mathematics, and all these things, that is very difficult to do, or that was very difficult to do back then with VHDL and Verilog, because there was not a lot of support, let's say, for standard mathematical operators. And that was not the case for Python. In Python, you could do a lot more things. And today, the library of available packages and everything that you can use is so huge that you have a vast library of everything that you wish for already. You don't have to write it or verify it anymore. You already can use it in your test bench, let's say. So that is a very important thing also, because we don't have a lot of people that can write system Verilog and VHDL. So our niche is very small, and having Python trained engineers, software engineers involved in the verification, yeah, you get not only a different viewpoint on what you are verifying, but also you increase the pool of people that can do verification, because there are vastly more Python capable people out there than there are system Verilog people out there, for example. So, and to see open source Python verification is, I think, a very, very interesting concept and a great thing to have, because there is also a UVM, PyUVM, for example, is the UVM variant in Python. So yeah, it's amazing what we have these days in open source EDA initiatives that bring a lot of value to the sector, let's say. So I'm all for it, and I'm experimenting myself with Python verification. I'm also myself I learned Perl in 1998 and I switched to Python forever in the year 2000, and I haven't looked back. So yeah, sometimes I have to do Perl, but my heart lies with Python. I like it very much because it's like C and C++, and C and C++ we also use for firmware and embedded software. So yeah, that's why I like Python so much, and I think it's great that we have this kind of verification environment now that we can take advantage of.
Yeah, that was a good explanation for it. And coming to analog computer now. So right now we also see many analog chips being taped out by various companies. So what role has UVM based or digital verification has to do with these analog chips coming up?
Well, it's not pure analog. Like if you look at MITIC's chip, it's analog, but let's say it's a flash-based analog calculation. You have a way of doing addition with analog currents, let's say, and resistors. But that is let's say, a macro that you use in your chip. And MITIC, for example, is tile-based, so you have a RISC-V plus that analog macro, which does the calculation, but they have other hardware acceleration also on that tile. For Accelera, the same thing. They have in-memory compute, which is analog mixed signal designed, but this special hardware accelerator is combined with other hardware acceleration things. They also are putting a embedded processor next to it. So yeah, a lot of the analog, let's say, needs a lot of digital. In this case, embedded processors. First, a system processor that does the setup of all the communication protocols, configures the chip, for example. And sometimes you have also application processors that run the actual AI networks using these analog macros, but they are never purely analog chips. And I think, yeah, your question was also UVM. Now, in the AMS world, the analog mixed signal verification world, we don't have something like analog UVM. We do have something that we can apply some of the UVM capabilities into the simulations we do with the digital, but we still have a lot of schematic simulations with SPICE and complex simulations that we don't have a way to do something UVM-like with at the moment. There is a standards committee working on a kind of analog UVM implementation, but we don't have that at the moment. But let's say I'm always in favor of doing as much as we can on the digital side with UVM and create a co-simulation environment with the analog where we use WReal models or real digital models where we simulate everything, but on the boundary and in the digital we use our UVM agents to drive and to monitor things to make sure that everything is going well. But yeah, we do have a problem on the analog side that we haven't solved yet. But I'm very confident that we are going to get something from the committee, the standards committee, and that we will have something in the future. But it isn't there yet, and we are trying to do what we can to bring the analog simulations to a sort of self-checking and a way that we can measure also the progress and what we are covering in the analog simulation. So, but yeah, it's a work in progress, let's say.
Yeah, that's an insightful explanation given. From what you have said just now, I can infer that co-simulation is what that's happening around in these chips.
Yes.
Yeah.
Yes.
So, yeah.
Yeah. So sorry, yeah.
Yeah, continue.
Well, pure analog simulations, we are looking at very tiny details with schematic simulations, with SPICE simulations and everything, but we don't have a way there to go in and say, okay, what do we need to have, because analog is in, well, it's in my mind a more fuzzy world, let's say. In digital you have ones and zeros, so that is pretty simple, and the reason why I chose digital, in fact, because one and zero is the simplest way of doing things. But yeah, you can say an HB or an HI transaction, you see that the data is transferred correctly, but in analog you are looking at small currents that need to be, and voltages, you are looking at parasitic capacitances, everything, but that's more like I describe it sometimes as magic, which the analog designers do to get a circuit working and simulating that it's actually behaving like it should. But all these little details inside the circuit, yeah, that's very difficult to probe and say this is within the limits that I expect, and connect something, a monitor to it, and see that is in a certain range. That is not really like how analog designers work. They mainly work still with waveforms and looking at the internals of a circuit and seeing analog waveforms and seeing that something let's say a stimulus that they apply, that the outcome is as they expect, with a damping effect or something, and they are looking at it just visually because they see that something has a result or an outcome, and that is acceptable. But putting something like a decay into a checker, that is very difficult, and that is I think still a big challenge for the standards committee, because they are working on it already a while, and I haven't seen a standard come out yet. So the challenges on the analog side are far bigger than on the digital side. Like I said, ones and zeros and data is much more easy to capture and to quantify and to check than what you have in the analog world. And don't misunderstand me, the analog designers, they are very, very smart people and very capable in what they are doing. But yeah, it's because of the continuous nature of analog, it's very difficult to standardize that with a verification methodology like we did in digital.
Pretty interesting. At least for me, I didn't know that there's a standards committee that's working on this part. Thank you for that, Bert. So coming to your career now, so within this experience of 25 years in semiconductors in various companies, starting from NXP to Accelera and Inatera now. So what were some of the interesting projects that you were involved in? At least for you, what were the challenging or interesting projects for you?
Oh, yeah, there have been so many interesting projects, but yeah, the first time that when I joined Movidius, I joined Movidius as a USB expert, because in my career, since the beginning, and one project had USB, another project didn't have USB, but USB came back a lot of times in my career, let's say, in the beginning. So I worked on USB 1.1, and then later USB 2.0, and then USB 3.0. So there, Movidius needed someone to do the silicon validation of the USB for 2.0 and 3.0. They needed it for device operation and for host operation. So they sent me a USB protocol analyzer, and I started working on the firmware, let's say, to do the USB 2.0 operation and later the USB 3.0 operation. So that was yeah, very interesting because they sent me 2 boards, 1 host, 1 device, and to make everything work and the maximum, let's say, bandwidth, the maximum data throughput. That was very interesting to do because yeah, the USB protocol has these time markers, micro frames, where you have the ability to send data, and then based on the size of your packet, you can put more or less packets in that time frame. And so the whole optimization of getting as much data as possible through it, that was very interesting. And then later on, and that was the first time that I worked with a network on chip design tool, because in the past we used network on chip design tools, but they were not very complex. But in 2016, I started working with the Arteris NOC, which was a network on chip that had enormous amount of parameters that you could configure. And we stripped out the old bridges and everything that they had in the Movidius chip, the Myriad 2, and we put in a NOC in the Movidius X. So configuring that and getting that to work with all the masters and all the slaves in the system was very interesting. I also did something similar in Accelera recently. So network on chip, that getting that to work and have the maximum throughput, have let's say statistics collected, things where you simulate. That was also Python based, by the way. You could put your masters and slaves and control them in Python and try to see if you have multiple masters having their specific traffic go through the bus at the same time, what the performance would be, the latency would be, and stuff like that. That were these are the interesting things to set up and to verify. So these things were in my mind very interesting things to do. At the moment, yeah, that is not what I'm doing, but I think on the other side, verification specific, where we integrate analog with digital, and that I've been doing now a few times, and setting up a UVM environment and making it work on the top level with the embedded software, C++. That is also one of the very interesting things to do, because yeah, it's a huge challenge to get the chip verified these days, because these chips are so big, and especially in startups, we want a chip to be first time right, or to have a little bit. Sometimes we can do. We hold a few mask layers to do still some echoes. So fixes in metal mask, but we don't want to have to pay a second time a full mask set for the same chip. So verification is so important for startups, also for big companies, of course, but they can take a hit a little bit on their budget, while startups cannot. And verification is the key to a successful startup. So that is also why, let's say, since 2015, 2016, yeah, I've been focusing more and more on verification next to my design activities.
That was pretty interesting experience that you had with all these projects. So, what has been the craziest decision in your career?
Well, in my career, craziest decision, yeah, I was working for NewTek. They were doing satellite modems, so they were working on so there was DVB S2 standard in satellite communication, and the CTO of NewTek, which retired later and was introduced in the Hall of Fame of the Satellite Association. He was working on better modulations and FEC rates to get more throughput over satellite. And so, yeah, we worked on that, and it was very interesting. but at the same time, I was having kids, and yeah, I was not seeing my kids a lot because of the work. And yeah, we took a decision around 2013, 2014 to just sell everything, because we were living in Belgium. I'm a Belgian by birth, so my wife is also Belgian, and we decided to talk about yeah, moving to a more a sunnier country where the sunshine is very important. In Belgium, we have a lot of rain, so that is not so great for let's say for your mood and your well-being. It's very important to have a lot of sunshine. So we were talking, do we move now when the kids are little, or do we wait until retirement and then move to a country in the Mediterranean? And we took the decision, and that was a crazy decision, because we sold everything in Belgium and we moved to Portugal. And in the beginning, we didn't have anything. Like, I didn't have I was still working a little bit for New Tech, thank God, New Tech. But yeah, we didn't have a plan to have a career like I have now, to work mostly remotely for things, for companies, because yeah, before the pandemic, everybody was saying, yeah, you cannot work remote for a ASIC company, because yeah, it's not possible. Yeah, we use VNC to log in a server that is God knows where in the world, but yeah, you cannot work remotely. Until the pandemic, it showed that it can be perfectly done. So back in the day, in 2015, 2016, like that. So that was a really crazy decision to have no job security, no, let's say we didn't have any site for the next contract or something. So it was a period of uncertainty, but I'm glad that we did this, because yeah, it has been a very interesting journey. And yeah, I don't think if I would have stayed in Belgium that I would have worked for so many international AI companies, for example. So yeah, it turned out better than I expected, but yeah, that was not a given at the moment. So that was the most crazy decision that I ever took in my life. It was a little bit, yeah, private, and a little bit, let's say, career. Sometimes, yeah, people were saying career suicide, that you just, I like the job very much, but yeah, moving with my family to Portugal in this case was crazy decision that yeah, I think it has turned out better than expected, and yeah, I'm very happy with that.
Yeah, glad for that, and that was quite an experience and a decision that was taken. But so it feels honored to speak with guys who have got experience across the stack, across the computing stack. At least as an ECU engineer myself, I feel honored to speak with a person like you who has got experience on embedded, quite a bit of experience there on VLSI design as well, and also communications as well throughout your career. So we don't find so many guys like you nowadays, because nowadays we don't get to work on various subdomains like you people did back then.
Yeah, it's true. Yeah, you know, everybody that started in the 90s, they have either, yeah, some people changed jobs to a different path in their career, or they moved up the ladder to go director, vice president, or start their own startups. Yeah, you have people that yeah, there are not so many people left that are still doing technical things, let's say. Yeah, even now I'm director of verification, but I'm still doing the setups with make files, running simulations, checking test cases, writing my own test cases. So yeah, that is after 25 years. I still enjoy doing that, and I really like that this technical is still part of my life, because that also allows to mentor people and to explain to people how things evolved and how things interconnect, let's say. And that is something that I saw in Movidius, for example. The VP of engineering was Brandon Barry. He was the VP of engineering, but he was every day still able to go in, install a tool that you needed to reboot the server, to do a simulation. He was always technically capable of doing all the things in the front end design part of the project, but also he was very good in backend and the layout team coaching and getting them to do the things that we're doing. So he is a kind of an example for me to let's say do a sort of management role, but still be able to do everything technically and doing these things also technically, so that you can be an inspiration for your team. That's very important, I think. Yeah.
Yeah, he was a VP, but engineer for life.
Yes.
Yes.
Yes, I think so. That there are some people in this world that want to keep doing technical things and are interested also to do technical things. While when I started in the 90s, I saw a lot of people that wanted to get rid of all the technical things and become just a paperwork and phone call and meetings and everything. And you see that a lot in big companies. They have a project manager, they have a team lead, they have verification lead, a design lead, and these a lot of people they just get lost in meetings and wasting their time, and they are not doing anything technical anymore. And I just think that this is yeah, you are not keeping touch with the technical evolution, with the design and what the designers, verification and synthesis engineers are facing every day. How can you defend your people if you are not really doing the job anymore that they are doing and facing the difficulties that they are facing? So I believe that excuse me, that you have to stay in the technical realm, even if it's just a few hours a day or a few hours a week. You still need to keep the pulse of the team and know what they are doing, know what they are facing, and then you become a much better manager, I think.
Yeah, got it. That's again a good point. But so talking about starting out in VLSI and freshers now. So what do
Mm-hmm.
you mainly suggest for freshers who are applying for jobs in VLSI industry, especially maybe front end, let's say?
Yeah, the thing is, there is a sort of catch-22 situation. You need to have experience to get, but without getting hired, you cannot get any experience. But back in the day when I started in the 90s, we didn't have open source projects so much. We didn't have single board computers that were very affordable. We didn't have FPGAs that we could afford to buy. Today, you have FPGA development boards, even if it's an old Vertex 6 or whatever you can find for a few tens of euros. You can find a board. You install the FPGA software that you can download from the internet, and boom, you can start to design your own circuit in FPGA. You can do verification. You can see what STA is about. It's not really ASIC STA and not really ASIC synthesis, but yeah, you can't complain about free tools if they just give you the free tools. So, but it's a starting point where you can work with real, you can start with open source things that you can put on the FPGA and see how it works. There are so many websites these days where you can find interesting projects.
We even have PDKs, open source PDKs right now.
Yes. That aside, I would start small. Let's say, small. Let's go to GitHub, and there are many projects, FPGA projects and source code where you can look at how system Verilog is, or VHDL if that is your thing. How designers design things, how designers verify things, and how you configure an FPGA with a new circuit. So I think FPGA boards is very important, but also single board computers. You have the Arduinos of the world where you can write C and C++ embedded software, but you have also more capable the real single board computers like Raspberry Pi, which have a kind of GPU. They have GPIOs that you can toggle and control your let's say irrigation system with, or do other things. There are so many nice projects out there and ways that you can just buy for less than 50 euros a single board computer and experiment and learn to write firmware and embedded software and how compilers work, how you debug all these things. That is a big thing that we didn't have in the 90s. Today you can, if you want, but that I don't see a lot from the people these days. If you don't find a job, focus on that. Focus on open source projects. Focus on buying an FPGA board, a single board computer, and doing things, experimenting all the time. Develop your skills, because if you can show something to the employer, like I did this, that, or I have in GitHub something, I built a UVM agent for a GPIO, for I2S, I2C, a communication protocol or something. Look, here it is. Look at my code. Look what I did. See my achievement. And I think that is going to bring you experience that you need to show before you can get hired. And I think that is in 2023, it's up to you to go out there and show yourself, gather experience, and invest in yourself.
Probably the most important part of the session for all the freshers. So as Bert said, leverage open source, leverage all the tools that you have currently on websites, on GitHub repos out there. You can definitely get the experience that you need and definitely find the job. Thank you, Bert, for that answer. So we're almost at the end of the session now. A couple of questions before we call it a day. So what do you think about VLSI for All and the work that you're doing?
Well, I think it's great. I have started myself in 2017 to answer questions on Quora, which is a Q&A site. So yeah, it was very interesting to see. I started with simple answers that weren't very good, I have to admit. But in 2018, I got an email from Quora, you are top writer 2018. And I was about to stop answering these questions on Quora because, yeah, I didn't get the motivation. In the beginning, it's very hard. Not a lot of people know you. Not a lot of people are reading you. And then I got this confirmation. And then, yeah, I started answering a lot better with more detail to questions. For example, also in 2019, I talked about the rise of India, for example, in semiconductors, and what we are seeing now, that they should be doing fabs and foundry. So in that sense, I think it's very important that there are people from the sector teaching or mentoring or giving information about what is not available and what is never taught in any course in university or whatever school, because we did those things and we know how things were going, specifically in ASIC design, and we know how these things are connected in a front-end design project in ASIC, and we can give tips and tricks to the more junior people, like this is the way that you avoid problems later in STA, for example. If you do this, then you get better results there or something. There are very practical tips that you won't find anywhere else, that you can give to freshers and to junior people. And I think it is very important that we have multiple ways to share knowledge, like VLSI for All. It's a very good initiative. So that we have different websites via different media like YouTube, that we reach the people and give them tips and tricks about technical things, but also for career and for applying to jobs and everything that we can think of. We can transfer knowledge to the people, because I think it's very important to know certain things about career, about technical things in ASIC design that are very important for juniors to know.
Interesting, and thank you, Bert, for your kind statements on us. So, a question from my side. So, we see nowadays we see a lot of children doing coding. So, writing Python code, writing C or C++ code. So, is it also possible to, I mean, make them do logic design? Because, I mean, at least digital logic gates are easy to begin with, even for, let's say, 10th grade children. So is it I mean, will it be easy for them to get started with at their age, children studying 10th grade, and will it be useful for them? I mean, how do you see about this?
Well, yeah, I think in a lot of coding coding for children, they learn concepts that we also apply in hardware, like selection, if then, else structures, and or functionality, that if something is true and something is true, then something will happen. So I think it's implicit already there. So I don't think it's a big step to teach them about the basic logic gates, where you can the and, or, and the not, the basic of Boolean algebra, where they can construct any complicated circuit with digital circuit with these three basic building blocks. I think it's useful, but I'm not sure that children would be interested as such, because you can code and see a program running, but going to hardware is always a little bit more difficult and a little bit more abstracted, because yeah, we are configuring an FPGA or an ASIC and we see waveforms and see things toggling, but that's not the same as having a software program that prints out a calculation, or let's say ask you your name, and you type in your name and then it prints your name on the screen. And there are some I think it's very important to steer people to also consider the hardware world as a viable career option. But I think it's difficult to do when they are children, and yeah, software is more easy than, in my mind. You only need a laptop and an internet connection to do software, to do app design, to make websites with some scripting and stuff like that. So we are at an abstraction level higher, I think, and the hardware industry, I think, has a problem in the sense that how do you get people interested in hardware? But I think maybe the fact that there are small FPGAs out there and also Arduinos now with an FPGA next to them, that can maybe help people consider doing logic design. But I think kids are more inclined to do software, and that we towards the end of the like 16, 18 years when they have to decide about going to college, university, that is then an ideal moment to introduce them to something about Boolean algebra, logic gates, how digital and analog circuits work. But yeah, that's my thought. I'm just my idea. I think when they are 10, 12, 14, they tend to do a lot of games. They can do with software, make their own environments, do 3D design, and they're probably not so interested. I think also because I have kids in their teen years. I don't see a lot of interest in the digital circuit world, let's say. But yeah, it's certainly a challenge to get people interested into our line of work. And yeah, I can think about it, but I don't have a good solution at the moment.
Yeah, thank you for that, Bert. It was an interesting answer. Yeah, even I agree with you. It's not very easy to get people get interested in this domain, especially children, as you were saying. So, looking back 25 years ago, young Bert who is joining VLSI industry just then and moved all these years into 2023 now. So, what are some of the, I mean, experiences or advices that you want to give young guys who are just starting out, just like you 25 years ago?
Yeah, well,
career
one
or
thing
general?
Sorry?
Career or general advices?
Yeah, I think career-wise, I think, well, there was this there is this quote like the illiterate of the 20th century will not be the people that cannot read and write, but the people that cannot learn, unlearn, and relearn. That's from Alvin Toffler. So something very important is that people do not understand what a career is when they start a career. So a career can be in direction of management or more technical to become an expert. But I think it's very important that people realize that companies are not your family, even though they pretend they are family and we are all friends. And you don't kick out family when now economically it goes a little bit more difficult, and then they kick out parts of their family. So that is not really true. So what can you take away from a company is that your salary will the next employer give you the same salary or the same title or something? No, that is not never going to happen. You can't take your title or salary or whatever with you, but you take with you your knowledge, your skills that you learned. And that is very important, I think, that people understand that they have to, every engineer is taught that in college. You have to keep learning, but people sometimes stop learning when they say, oh, I have a job now. I stop learning a little bit. I learn a little bit about the project and that's it. But that is not how it's done. Only when you have several skills, a skill set, it is the most valuable thing that you can build, because you are increasing your chances to get hired or to start something yourself when you have different skills that you combine. Because 1 and 1 in this case for skills is not 2, it's 3 or more. When you have a talent stack of different skills, you see a lot of interconnections and opportunities that you can't see if you don't have that skill set. And I think what you take away from your company is your skill set and what you learn. So you always have to understand, am I still learning things on a daily basis? Am I still interested and finding out things or not? If it's not, then it's time for you to consider how you can learn more, and keep learning other things. Maybe talk to your manager, see that you can do a little bit of different task, move to a different group, a different department within your company. If that isn't possible, sometimes managers don't want to. Let's say that they have an FPGA guy and he wants to do verification or join another department. He's going to have to replace you, train a new person in your place. So he's usually not so interested. So don't be afraid then to look outside your company. You have to keep learning because your value is linked to your skill set, not to your title or your salary or whatever you think you have. I think it's very important that you keep focusing on learning. It's a continuous learning journey. And yeah, I think that is the most important advice that I can give myself when I was young. By accident, I did the right, sometimes the right things. I learned a lot, but yeah, you can easily get stuck into some job, let's say, without a future, without much learning, and then you actually dupe yourself because you limit your future, and that is a problem. I think you have to always focus on, am I learning something? Where can I learn more? What is my next step? Keep learning.
It's the biggest takeaway out of this session for anyone placed at any stage of their career. Continuous learning is the key, is what Bert says,
Yeah.
and it's in fact true for anyone in any industry, not just VLSI. Thank you, Bert, for all those inspirational takeaways from this session. And it was an insightful session with respect to advisors and also on technology part. And thank you for all the words that you said in this session. And thank you for spending your time with us to give all your advices to our audience.
Thank you for the opportunity because yeah, I've never been interviewed, so this was a first. I'm always open to share a little bit of my experience, let's say. So I'm always open to that, and I thank you so much for inviting me. And yeah, I can only hope that it has been very useful for your audience. So thank you for inviting me, and yeah, keep going.
Thank you, Bert. We'll surely keep in touch with you. So
you.
with that, we come to the end of this session. I guess all the audience have many takeaways from this session. Thank you all for joining us. We'll be back with yet another session. Goodbye.
Bye.